In the third part of this Vellum basic introduction tutorial, I want to show you how you can set up Vellum simulations inside DOP networks and what's the difference here and why you should do it. But before that, let me mention one more thing that just came to my mind that's maybe important here, because I just took a look at our Vellum post process. And now I have these different geometry streams here, these different geometries. And if I have one Vellum post process here right now, and I activate this, you see that automatically, of course, all of the settings of this Vellum post process are applied to all of our geometry. If you do not want this, for example, the subdivision type of loop is good for our triangles, but it's not good for this mesh here. So you can, of course, also separate these streams right here. And you can do this by split. So if I put in a split node, let me put in a split node here, after our Vellum solver, or in this case, our Vellum IO, this actually doesn't do anything here. But if I connect this here and take a look at that, you can split this now by groups. And if I use the cloth group here, you see what this gives us. Now we only have our cloth. And now, of course, I can use this Vellum post process here and apply it to my cloth. And then only this will get thickness and will get the subdivision here and the spatial blur that we actually don't need in this case. But of course, we lose the data of our constraints. But this is an option. So you can do this like that, create a second one over here. Let's actually delete this connection to the merge here. Choose on the second split, you just choose the soft body. Now you have the soft body. Now we can change. We don't need any extrude by thickness, and we just use another subdivision mode here. Oh, actually, this did not work. Why did this not work? We are on air because the cloth is still in here. I have to clear this out and only put in soft body. Of course, now this works as expected. And you see now we get a way nicer subdivision here because this Catmull Clark is just subdividing quads. And now we can bring this all together into our merge. So yeah, now this way we have this nicely separated, and we have our Vellum cloth here with our thickness, and we have our soft body that is nicely subdivided as well. Now let's rearrange this a little bit, just for that everything is in order here, like so. Yeah, good. Okay, now let's take a look at Vellum setups inside DOP networks and why you may want to do this. So to create a Vellum setup inside a DOP network, let me quickly turn off all of my two setups that I already created. And now I will make this a little bit different. So again, let's create a geometry node here. But this time I will call this my source object. My source object. And again, I want to use a file node to make this a little bit more interesting. And again, I will load in one of my objects of my pack here. So let's load in a funny object, maybe one of these bubble things here, maybe this one here. Let's choose this one. Let's take a look what this is. Yeah, this is pretty perfect. That's good for Vellum simulations. So this is my source file, and I will just bring a null in here and call this out source. And I can just colorize this green because I like to colorize my out nulls green. So if we want to create a Vellum simulation in a DOP network, we also have to assign constraints. And we have to assign the constraints actually on the geometry. So right here in our geometry environment, I want to add constraints. So let's do that. And in this case, we will set up Vellum constraints. And let's see, I will use balloon constraints for now because this is quite a funny setup. And we have these cloth things here and we have pressure. So again, we have two constraint nodes that are actually now creating constraints on our object. So let's do it like this. And now I cannot run any simulation because I have no solver in here. And I will also not create a solver here. So I will create a DOP network now and feed this in. If you want to create a DOP network, I could do it right here. So you can do it right here. Oh, this was the wrong one, sorry. DOP network. And dive inside here. Now I am inside my Dynamics environment, inside the Dynamics operator network. But usually, or if you use the shelf tools, and I will show you this later, your DOP network will be created here on the objects level. So this is why I want to do it also here. So let's create the DOP network here. And let's add it in here. And let's call this our Vellum simulation. And just that we know it, I will just write in here DOPs. And here, just that we SOP, just that you know what this is, because as I said, you can download this project file on Patreon, and I will really write a nice documentation so that this can guide you through setups like this. Okay, DOP Vellum simulation. Now, we need a few objects here, a few nodes. First of all, we need a Vellum solver, of course. So you see right here in the dynamics, there's also a Vellum solver that we can just enter here. Then we will need a so-called Vellum object. The Vellum object will go into this import. You see here is object to solve. So let's put this in here. So how can we get our object now into our simulation? And therefore we can use a Vellum source object. So let's use the Vellum source. And we can apply this, or we can plug this into this third input here. So this post-process solve here. And here we can now specify a SOP path. SOP path is surface operator path. So let's go in here. Let's move to our objects. Let's move to our source object and choose this out source. And actually now I made a little mistake, because if we go back to our source object, I forgot one thing. I only added the geometry stream, but we also need the constraint stream. So let's call this outsource geo, create another null here, connect this to the constraint stream and call it constraints. So that we have both of these in here. That's important. You want to pass the object, the geometry, and the constraints here into the Vellum simulation. And you see here we have the constraint subpath, and here we just bring in, let me bring this over. Here we just select our outsource constraints, accept. Now, if I go into my file here and just add a transform to move this up a little bit so that it is not sitting on the ground floor like so. And now if I activate my DOP network and I start to simulate this, nothing is happening. So why is nothing happening? Because right now we have no force in the scene. If we take a look at this solver here, this has no force tab. So inside the DOP network, the solver itself has no forces. So we have to apply our gravity here. So let's apply a gravity force. And we can actually just plug this in here. And now if I go up and if I run the simulation, you will see something is now happening. And let's turn this off here because we don't need this to be visible. You see now my object is falling down. But now I have no collider. And if I go to my DOP network and on the solver, there is also no option to add a collider. So to add in a collider object manually, let me show you how to do that. We can create a new geometry node and call this our floor. And on our floor, we will just, and I will now turn this into ghost other objects that we see what we have here. I will just create a grid now. And this grid should be our collider. So just create a grid, and yeah, the resolution and the size is fine. And you could now again put in a null here because this makes it a little bit easier later on, and call this out floor like so. Make it green. Okay. And now let's go into our DOP simulation. We have to bring this grid now into our DOP simulation. So to do that, we need a static solver. And please stick with me. You know, I know that this is very confusing here, everything, but yeah, if you learned it one time and if you really understand what's happening here, then it makes sense and it will enable you to create really, really cool complex setups. So please just stick with me and let's build this together. So we need a static solver. You see, if I put in static, I have static solver. And we actually plug this into this merge here that I created. So this merge here. And I also want to bring in a static object. So let's bring in a static object that we just connect here. And the static object again has a SOP path that we can specify. So we can now specify our floor here and choose our output here. And now this is in our simulation. And if we run this simulation, now I can also run it here in the DOP network actually. You see now it falls down and it will collapse on our floor. And you see also that now, yeah, the struts are a little bit weak and we can change that. There is a trick that is quite nice. If you press, for example, Ctrl and then 1, you will set a quick mark. And if I go up now and into my source object, let's delete this here actually also, or let's make it invisible. In my source object here, where I set up my constraints and press Ctrl 2, then I set a quick mark 2. And if I press now 1 on my keyboard, I jump into my DOP network. And if I press 2, I jump right into my source object. That's really good if you want to change between your setups quickly. So let's go in here because I want to increase, actually I created a pressure here, a balloon setup and not a strut setup. I forgot this. So let's make this a little inflated. And first of all, I want to increase the stiffness here of my balloon, make it quite stiff, and increase the stiffness of my pressure constraint. Set the rest length scale to something like 10. At some point, something funny has to happen. So let's take a look at that. Yeah, right now it is inflating a bit more. As you see, now I have this balloony thing dropping down. So that's kind of funny. Okay. Now, and again, let me mention, if you want to learn how to really set up things like inflating balloons and all that stuff, then please check out my Patreon and my website. I will put a link into the video description. There you can learn all these crazy and cool things you can do. But what I really wanted to show you is the reason why you can use or why you should use Vellum inside the DOP network sometimes. If you want to add additional geometry to this simulation, there's no way to do that inside a SOP network. So there's no way to do this in our basic setups here because you cannot really add new geometry to the stream. But you can do it here in the DOP network. And this is pretty cool. So let's reset our simulation. And let's add in a few more of these objects. You see, here we have an emission type that is set to play only once. Now, if I set this to each frame, I could either do it on, I could also do it on each substep, but yeah, even each frame is too crazy. But let me run this now only for a very quick time, and you will see what's happening here. It is creating a new geometry for our simulation each frame, which of course makes not much sense and it will get crowded very fast. So instead of using the activation of 1, we can put in an expression here. Let's type in $SF, that stands for simulation frame. Then we create a modular function. I do not want to explain this now. Just type in the same thing that I do, is 1. And if you put this in exactly as I did here, then you will create a new object every 20 frames. So let's start the simulation now. You see here's the first one, 20 frames, second one, 20 frames again, third one. So this is a pretty funny setup. And you see, this is the power of using Vellum simulations inside DOPs, because then you are able to add to your simulation. There are some other use cases where this is really useful to set up a Vellum simulation inside DOPs. But again, more of that in my Patreon, in my Vellum Playground course. Good, so this is it with the setups, the manual setups. Now I want to take a look on the shelf tools. And if I do this, then you will see why I actually went through this process of setting this up manually, because the shelf tools create exactly these networks that we created manually, and it's very good to know how this works. So let's take a look at the shelf tools. I will just turn off everything in here that I have here. And I will create a new geometry here. And I will just use or just create a sphere here. Just make it very simple now. Create a sphere in here and do nothing else. Actually, do one more thing. Let's change this to polygon and let's set the frequency to 4. Just that, yeah, we have something. Now this is my sphere. If I want to create a very, very fast, simple setup, Vellum setup, inside SOPs, inside surface operators, you have to do the following. So let's deselect everything. Let's go to Simple FX. And here you can see simple cloth and simple soft body. So let's say I want to create a simple soft body out of my sphere. Select this one here. And now it says select an object to turn into soft body and press enter to complete. So let's select our sphere and press enter to complete. Now select a collision object, if any, and press enter to complete. Right now I have no collision object, so I will just press enter. Just to show you what Houdini does now. You see that it calculates a bit, and now we suddenly have something very, very similar as we created before. If we go up one level, you see that it actually created a new geometry network, a new geometry node. It just used an object merge to refer back to the sphere that we created. Then it created a tetrahedral soft body. That's also a soft body type that I do not want to discuss any further right now, but it actually requires 2 steps. It requires this tet conform here and then this tetrahedral stretch constraints. This is just another way of creating soft bodies. So this is just a standard Vellum constraint node. It created the Vellum solver as we did. It created already a Vellum IO and it created a Vellum post process. So it created all of these things for us. And if you want to create your own collision geometry, you can simply add in a grid, add this to the collision stream now, move it down a little bit. And then you can run your simulation and you see that everything will work as expected, except that the constraints for this tetrahedral thing are a little bit too weak. So if we go in here, you see the stretch constraint is set to 0.01 and this is way too low. So let's set it to 100 and we will get definitely a better result here. And you see now it's very wobbly, but it keeps its form a little bit. And if you go higher here, then of course, yeah, you will get a stiffer shape. So this is how these things work. This way you can set this up using these simple effects. And with the cloth, it will actually do exactly the same. So you don't need to do it manually, but it's very good if you know how to do it. So this is our example for a simple soft body. And now let me show you actually these Vellum setups that we have over here. Right here, you see we have these Vellum setups. And let's also make an example here. So I will go to create a new geometry node. And again, I will just create a planar patch here. So name this cloth. So I go in here and create a planar patch as I did before. Planar patch, oops. And just make it again big. Change the resolution. I will do exactly the same as I did before. And I will move it up here. Let's actually use a transform node and move it up 2 meters. Okay. This is my cloth. Now let's add in another geometry node so that I can show you this also. And this will be my collider. So torus, collider. Let's add in a torus here. I will rush through this a little bit now. And I will add in a transform and set this to 1 meter, right, like that. Now I want to create a simulation out of these. So how can I do that? Let's select everything, I deselect everything. Let's go to Vellum and let's select Vellum hair. Now it will say select objects for Vellum cloth, or actually Vellum cloth, sorry, not Vellum hair, so Vellum cloth. So I select my planar patch here, select it, and press enter to accept. So let's press enter to accept. And now if I press L here on my layout, you see I am suddenly into a DOP network. And let me turn off all the other things that we don't get confused. And oh yeah, what it did now, this is very interesting now. This was not what I planned, but good that this happened because yeah, this shows you another thing that Houdini is intelligent. What it did, it actually added my Vellum planar patch that I created into my existing DOP network that I created before manually. If you take a look now, I selected this one here and said I want to create Vellum cloth out of it. But instead of creating a new DOP network that this would actually do, it added it to this existing Vellum DOP simulation that I created before. So what we have now is the following. We have this cloth inside of my simulation. That's pretty cool. I didn't plan this, but yeah, let me show you this now, what usually would happen. And to do that, I think that I have to delete this DOP network actually. So I will just do this for a moment. I will save this file so that I don't lose everything. And then I will just delete it for a moment. So all of these things that I built manually before. So let's go back now because now I have my cloth in here and my collider. Let's deselect everything. Okay, now let me show you this one more time. But before I do that, I have to clean out my constraints that were created now. So now I'm back. Let's delete this. Now I am back with this cloth here and I'm back with this collider here. So let's try this again. And let's make sure that we have no constraints in here. This is now how I set it up. So let's deselect everything. Let's go to Vellum cloth and now select my object that I want to turn into cloth and press accept. And now Houdini is calculating and actually already solving around here, which I don't want. And you see that now it created a DOP network for me. So it created exactly the same setup that we created manually before with a Vellum object, Vellum source, Vellum solver, a merge here, and a gravity node. And if I press play now, you see that this will fall down because of the gravity node. We have no colliders in the scene. If you take a look now, what it also created, it created a Vellum cloth geometry here. So let me move these out of the way. These ones were these ones that I created. I will color them pink. And these are the ones that Houdini created automatically. So in the Vellum cloth here, we have an import geometry. We have a remove attributes. So here it removes normal attributes. Then it sets up some things that you don't need to know. And it imports the geometry, the constraints, and adds a Vellum IO and a Vellum post process. So what we see here is actually not the DOP network. It is this node here. This is kind of an export. It just gathers the information from the DOP network by using this DOP import node. So here it refers to the Vellum object and to our DOP network that were created. Then it runs it through these setups that, yeah, you actually don't really need, but they are here. And then you have Vellum IO and the Vellum post process. We're already familiar with these two. And it also imports the constraints from our DOP network. So what you can see now is only this node. If you turn this off and activate the DOP network, you will also see the geometry. But just be aware, if you use these auto functions, it will create this geometry node where it imports all the data from the DOP network. So this is important to know. Now, if I want to add a collider into the system, my torus collider here, we will do the following. Let's go to the DOP network. Let's go to collisions and choose static object. So let's select static objects, and now it says select an object for static object, and we want our torus to be a static object. And now press enter. If we take a look now at our auto DOP network, and I press L again to lay this out, it added a static object, collider, a merge node, so that you can wire in different static objects if you want. The same applies exactly for this source. You could also add more Vellum source objects here. And then you have the static solver that is now solving this with the gravity. So now if I press play, and please again be aware that we are looking at this geometry node, not at the auto DOP network directly. Now this will fall down and it will collide as we would expect. So this is probably a little bit confusing, and this is exactly why I didn't want to go that way from the beginning, because these automatically created networks are very complex for beginners. So I don't want to make you too crazy. I know there's a lot to process here, especially if you are a Houdini beginner. This gets very confusing and can get frustrating, but please really work through it step by step. If you really wrap your head around how this works, it's not that complicated anymore. And there's one thing I want to show you. If you now want to add additional forces, there are two ways you can do that. I showed you already the pop force, and let's use this also. So let's use the pop force that we already know. And if I want to influence my Vellum simulation now with the pop force, I can either wire it in here. So in the particle forces, this will work. So if I now set this to 5 and just go up here, we will have a directional force, and you will see that it will blow away my cloth, like so. And there is another option if you want to limit forces to a certain stream here. So for example, if I want to limit this to this stream, then I can also use this pop force and wiggle it off here and put it in here. And actually, let's put it in before the merge. This makes more sense because it's possible that we bring in different cloth sources here or Vellum sources, and then you can wire it directly under your Vellum source, and then it will influence only this stream. So this will have the same result. But if we put in now another source, and I can do this by just duplicating this, like so. Let's deactivate this for now. And you see we have our wind in our simulation. Now let's deactivate this one, and let's activate this stream here. And now you will see no wind is affecting it, because this pop force now only affects this stream. So this is also something that is very cool in these dop networks, that you have a lot of control which forces are actually interacting with which stream, and that you can also add new objects into your simulation by just using this as an emission. Okay, so this is it with this basic dop network setup and with the basic introduction to Vellum. If you want to learn more about Vellum, and if you want to learn how to use all these things that confused you now, then I would recommend to visit my website. There I have a Vellum course that is currently running on my Patreon. And I would really appreciate it if you support me there, because this will enable me to create even more and cooler educational content for you guys. Thank you very much for watching this tutorial. I really hope to see you soon. Goodbye.